In this podcast episode, neurologist and author David Perlmutter delves into the intricate relationship between diet, metabolism, and brain health, focusing in particular on the detrimental impact of ultra-processed foods. He discusses groundbreaking research linking metabolic dysfunction to Alzheimer's disease and other neurodegenerative conditions, explores the role of the brain's immune system and microglia in health and disease, and emphasizes the power of lifestyle choices in shaping cognitive outcomes. The conversation also touches on biomarkers, genetic predispositions, emerging therapies, and the evolving landscape of prevention and personalized medicine. David begins by highlighting the metabolic chaos induced by a diet rich in ultra-processed foods, known to contribute to obesity, type 2 diabetes, and cardiovascular risks, but less commonly appreciated for its direct effects on brain health. He cites a landmark 12-year study from the Framingham Heart Study showing a 13% increased risk of Alzheimer's disease per serving of ultra-processed food consumed, with those eating 10 or more servings daily facing a threefold increase in risk. Similarly, a separate study published in JAMA Neurology followed over 10,000 individuals and found a 28% increase in global cognitive decline in those with higher ultra-processed food intake. While these findings are correlative, Perlmutter asserts the evidence collectively points to a substantive metabolic underpinning for neurodegeneration linked to diet. A core theme is the intimate link between whole-body metabolism and brain immune responses, particularly involving microglia, the brain's resident immune cells. These cells can exist in a supportive M2 state or shift to a destructive M1 phenotype that drives neuroinflammation, synaptic loss, and impaired neurogenesis. Perlmutter explains that the metabolic status of the body influences this polarization. Mitochondrial dysfunction in microglia prompts a shift towards M1, exacerbating inflammation and brain damage in conditions like Alzheimer's, Parkinson's, and even psychiatric disorders such as major depression and PTSD. This shift may continue in a feed-forward cycle, whereby inflammatory cytokines produced by M1 microglia further propagate neuroinflammation and neuronal injury, explaining why neurodegenerative diseases worsen even after initial insults. The discussion stresses that the seeds of neurodegenerative diseases are sown decades before symptoms appear, often in one's 30s and 40s. Clinical manifestations such as memory loss or olfactory decline emerge only after extensive metabolic and immune dysfunction have taken root. Perlmutter advocates for preventative measures to begin early, focusing on metabolic health as a critical intervention point. He notes the high prevalence of undiagnosed prediabetes in adults and the utility of direct-to-consumer laboratory testing to empower individuals to monitor key biomarkers like fasting insulin, blood sugar, homocysteine, and uric acid. Such testing provides actionable data to personalize lifestyle adjustments before irreversible damage sets in. Perlmutter describes his approach to dietary recommendations as outcome-focused, rather than dogmatic about specific diets. Instead of adhering strictly to labeled diets like Mediterranean or ketogenic, he encourages a diet that maintains tight blood sugar control, is plant-forward with abundant fiber and polyphenols, supplies adequate protein, and emphasizes healthy fats. He underscores that fats were historically maligned, but are essential for neuron structure, metabolism, and inflammation regulation. The avoidance of ultra-processed foods remains paramount given their pervasive role in driving metabolic dysfunction. He also ties diet to social and environmental dimensions, remarking on the disconnection between food production and health in modern society. A significant portion addresses how modern medicine is transitioning from reactive to proactive, emphasizing regular tracking of metabolic biomarkers to guide tailored interventions. The co-host introduces his own UK-based lab testing platform, focusing on a concise panel of 11 biomarkers related to metabolic and brain health, including fasting insulin, homocysteine, uric acid, and hemoglobin A1c. Perlmutter strongly endorses this approach, noting that many biomarkers considered normal in population averages are not optimal for long-term brain health. He stresses the importance of using such data to identify underlying issues, personalize diet and lifestyle, and consider pharmaceutical adjuncts if necessary, thereby moving beyond one-size-fits-all strategies. Perlmutter delves into homocysteine as a crucial risk factor for Alzheimer's and cardiovascular disease. Elevated homocysteine damages blood vessel linings and acts as a mitochondrial toxin, thus promoting neurodegeneration. Approximately 28% of people carry an MTHFR genetic variant impairing B vitamin metabolism, necessitating methylated B vitamin supplementation to lower homocysteine effectively. He highlights that normal vitamin B12 levels do not guarantee proper methylation, making homocysteine a superior functional biomarker. Regarding uric acid, Perlmutter explains its evolutionary role as a survival signal in response to fructose intake and caloric scarcity, triggering fat production and metabolic adaptations. However, chronically elevated uric acid contributes to mitochondrial dysfunction, insulin resistance, increased blood pressure, and vascular damage. Its ubiquitous rise today, driven primarily by high fructose corn syrup in ultraprocessed foods, makes uric acid a powerful indicator of metabolic stress and increased dementia risk. Exercise is presented as a potent modulator of microglial function and brain health. The skeletal muscle acts as an endocrine organ, releasing factors during activity that promote the generation of brain-derived neurotrophic factor, BDNF. BDNF supports neuron survival, synaptic plasticity, and encourages microglia to assume the beneficial M2 phenotype. Both aerobic and resistance training contribute to these effects, and flexibility and balance exercises reduce injury risk that could interrupt activity. Perlmutter shares his personal routine involving regular gym sessions, aerobic workouts, and gamified stationary biking for engagement and consistency. Research demonstrates exercise-induced increases in hippocampal size and improved cognition, underlining its critical role in neuroprotection. The hosts acknowledge the difficulties in motivating lifestyle changes, especially among older generations habituated to the idea that lifestyle choices have limited impact and that medicine will fix health problems. Perlmutter points out that this messaging has contributed to current epidemics of neurodegenerative diseases fueled by diet and lifestyle. He emphasizes the importance of focusing on younger populations who can benefit most from prevention while still offering support to older adults as best possible. The discussion also touches on how chronic inflammation from ultra-processed foods impairs the prefrontal cortex, responsible for impulse control and long-term decision-making, thereby perpetuating unhealthy behaviors and poor choices. Concerning alcohol, Perlmutter discusses the often-cited U-shaped curve relating alcohol intake to Alzheimer's risk, where moderate consumption seems protective compared to abstinence or heavy drinking. However, he stresses that alcohol is fundamentally neurotoxic, and benefits attributed to red wine polyphenols can be obtained from non-alcoholic sources without the associated risks. Social and cultural roles of alcohol are acknowledged, but moderation is key to minimizing brain damage. The conversation explores ApoE4 genetic testing, with Perlmutter strongly advocating for its use. ApoE4 is a well-established genetic risk factor for Alzheimer's, with one allele increasing risk 3 to 5-fold and two alleles amplifying it up to 12-fold or more. Yet carrying ApoE4 is a predisposition, not a guarantee, of developing the disease. ApoE4 influences mitochondrial dysfunction and creates a pro-inflammatory brain environment, exacerbating microglial shifts toward the harmful M1 state. Understanding ApoE status can motivate more personalized and aggressive preventive strategies and cognitive monitoring, moving beyond passivity. The hosts highlight that regardless of ApoE status, adopting brain-healthy behaviors is fundamental, but knowledge of genetic risk sharpens focus and urgency. Perlmutter points to the inspiring work of researchers like Dr. Dale Bredesen, demonstrating that early-stage cognitive decline and even mild Alzheimer's symptoms can be stabilized or partially reversed through comprehensive, multi-pronged lifestyle and medical interventions. Improvements include documented increases in hippocampal volume and restoration of cognitive functions, challenging the outdated notion that brain decline is inevitable and irreversible. The key is early and persistent engagement across multiple modifiable factors such as diet, exercise, sleep, stress reduction, and inflammation control. Throughout the episode, Perlmutter reflects on the personal values that have driven his lifelong work, including curiosity and compassion inspired by his own family history affected by Alzheimer's. He believes sustained behavior change emerges when healthy choices become aligned with one's identity and values, transforming from a struggle into a natural expression of self. This mindset supports long-term maintenance of brain-supportive lifestyles. He emphasizes the importance of adult executive function mediated by the prefrontal cortex in overriding impulsive decisions and the detrimental impact chronic inflammation has on this capacity. While lifestyle remains central, Perlmutter discusses promising advances in pharmacological interventions targeting metabolic and mitochondrial pathways relevant to neurodegeneration. Recent clinical trials of GLP-1 receptor agonists, originally developed for diabetes, show encouraging effects in Parkinson's and Alzheimer's by improving mitochondrial function and reducing inflammation. However, these drugs are not yet widely available or proven as definitive treatments. He advocates for an open-minded integration of lifestyle and pharmaceutical toolbox approaches based on risk-benefit considerations as the science evolves. In closing, the dialogue reaffirms that individuals hold significant power over their brain's destiny through informed decision-making, routine biomarker monitoring, personalized lifestyle interventions, and embracing the comprehensive view of brain immunometabolism. Despite the challenges posed by industrial food systems, medical inertia, and societal norms, adopting this proactive approach offers hope against the growing epidemic of cognitive decline. The conversation models how scientific insight combined with practical tools and compassionate guidance can alter trajectories for brain health across decades.